So ladies and gentlemen, you are all welcome to my YouTube channel. In this video, we are going to look at the MCQ on carbohydrate chemistry, and this PowerPoint is made by Dr. Ruchikayadu, and I'm going to make use of this PowerPoint to make this beautiful presentation. So now the first question to look at here is the question says a positive Benedict test is not given by A, lactose, B, maltose, C, sucrose, D, glucose. So first we need to understand this Benedict when you say a Benedict test. So generally carbohydrates are classified into two based on their reducing property. So we have what you call reducing sugar. We have reducing sugar. Then we have non-reducing sugar. So what is a reducing sugar? A reducing sugar is the sugar that have either free aldehyde or ketone functional group. So any sugar that have free aldehyde or ketone functional group are considered as a reducing sugar. And the other way you can consider it as a sugar that can be oxidized by a weak reducing agent. So of course, we know that from the definition of carbohydrate is a polyhydroxyaldehyde or ketone. So they must have aldehyde or ketone functional group. So all sugars that have the free aldehyde or ketone functional group are considered as a reducing sugar. So as a result of that, all monosaccharides are reducing sugar. Glucose, fructose, galactose, mannose, all of them are examples of reducing sugar. And of course, some of the disaccharides are also reducing sugar, because there is a situation where the aldehyde and the ketone functional group will be involved in the formation of the glycosidic bond. But in the case of lactose, only one of the one of the aldehyde functional group that is involved in the glycosidic bond formation. Also in the case of maltose, there is one free aldehyde functional group. Also for the glucose is monosaccharide, so therefore it's a reducing sugar. But sucrose is a non-reducing sugar. So a Benedict test is a test that is used to test for the presence of a reducing sugar. So it means that this test is specific for a reducing sugar. So this one is a reducing sugar. It means that Benedict test can give positive for lactose, it can give positive for maltose, and it can give also positive for glucose. But it's going to be given negative in the case of fructose, our sucrose. We know that sucrose is made of two monosaccharide sugar, and these two monosaccharide sugar is, we have fructose plus glucose is what give sucrose. So therefore the answer to this question is C. So let's look at the next question. So the next question is, the most important ephemer of glucose is, the ephemer is actually one of the form of isomerism that's actually when you have, like, for example, a carbohydrate with more than one chiral carbon. So you can have a situation where a molecule just differ with another molecules with just a single orientation, or with orientation of just OH group. orientation or with a placement of a position of OH group. So the best example of Epimer is glucose and galactose. So therefore, the most important Epimer of glucose is galactose. So therefore, in a simple way, when we said actually epimerization is just a difference in the configuration at a single stereogenic carbon, that is a numeric carbon. So if you check that, you see that in the epimerization, the glucose and galactose, they have the same functional group, the same number of carbon, the same number of OH group, but it's just a change in the position of one OH group. That's what makes them different. So that types of isomerism is called epimerization. And the best example for the epimerization or epimers of carbohydrate is glucose and galactose. So therefore, the answer to this is galactose. So now, let's move to the next question. So the analog of starch is glycogen. Of course, glycogen and starch, they are all polysaccharides. They are all polysaccharides. In fact, they are all example of polysaccharides. When we said homopolysaccharides, it means that sugars that have the same repeating unit or that have the same monosaccharides, the same repeating unit. It means that, like, for example, in the starch is made of glucose. So the repeating unit of starch is only glucose. There is no any other molecule. So it means that in the case of homopolysaccharide, the repeating unit is the same repeating unit you will be using to build off the polysaccharides. So therefore, starch is found in plant. It's a homopolysaccharide that is found in plant, and glycogen is also a homopolysaccharide that is found in animals. But what is the difference between the two? They are all made up of glucose, and they are all homopolysaccharides, and they are also they are also linked, all of them, they're linked by glycosidic bond. They all link by glycosidic bond. But the difference is that in glycogen, the glycosidic bond is alpha. Is alpha glycosid? Sorry, is alpha glycosidic bonds. But in the case of glycogen, it is made up by alpha 1,4 glycosidic bond in the linear chain, and in the branch chain is made up by alpha 1,6 glycosidic bond. So it means that glycogen is a branch. It has a linear. It's actually a branch. It's highly branched. And then for the starch, it is also a linear and branch. So the linear form of starch is amylose. And the branch form of starch is amylopectin. So it's made up of both linear and a branching. So the answer is B. So they are all storage form of carbohydrates. One is found in plant and glycogen is found in animals. So the answer is C. So it is the analog of starch. So then the next thing is glucose is a monosaccharide, and it is a hexose. It is hexose because it is made up of 6 carbon. So it is hexose. And then let's look at another question. So the linkage between two monosaccharides. So usually monosaccharides linked together. So the types of linkage that is actually exists between two monosaccharides is glycosidic. So glycosidic bond is the bond that links two monosaccharides together. In fact, not only monosaccharide, all the polysaccharides are linked by the covalent bond called glycosidic bond. And glycosidic bond is a covalent bond, is a strong bond. And then so let's look at the next question. So if carbonyl group in an aldehyde monosaccharide, if carbonyl group is an aldehyde, then the monosaccharide is called aldoses. And those that have ketone functional group, they are called ketoses. So this one, they are called aldoses. So then, so 3-carbon monosaccharide are called, so when you have a monosaccharide with 3 carbon, is called trioses. They are called trioses. So the answer is E, trioses. And those that have 4, they are called tetroses. Those with 5, they are called pentoses. So then a starch is a glucose polymer on which glucopyranose units are bonded by alpha linkage, beta linkage, gamma linkage, and none of the above. So it is bonded by alpha linkage, as an alpha linkage. And some monosaccharide have, some polysaccharide have beta linkages. We have some polysaccharide that have a beta linkage. So let me just give you an example of monosaccharide that form a beta linkage. Example of polysaccharide that have a beta linkage is cellulose. So it's an example of carbohydrates that is found or that have a beta linkage. So but the answer for this, because starch is alpha linkages. It's alpha linkages. So then let's look at, so the minimum number of carbons in monosaccharide is 3. So you cannot have actually a sugar or a monosaccharide less than 3 carbons. So the minimum number of carbon that is found or that is in monosaccharides is 3. So below that, it's not carbohydrates or it's not a monosaccharide. So example of Epimers, glucose and galactose is an Epimer, of course. Glucose and ribose, they are also Epimers. Mannose and glucose, they are also Epimers. So the answer to this is D, all of the above. Option A and C. Sorry, option A and C. Option E is a polymer, because this ribose is a 5-carbon compound. Glucose is a 6-carbon compound, so they are not Epimers. This is not an Epimer, but this one is an Epimer, and this one is also an Epimer. So the answer is the option A and C, because they all have the same functional group. They all have the same functional group, aldehydes. They all have aldehydes. They all have aldehydes functional group. This one have aldehydes with 6 carbon. All of them. This one aldehydes with 6 carbon. But only difference is just the change in or the change in position in the orientation of OH group. So the answer to this is D. So then the next thing is, the majority of the monosaccharide found in the human body are D. They are D type. We have D type, and L type is not found in humans, mostly in plants and other microorganisms. But we human, we have only D type. So, and then the next thing now is for the hydrolysis of starch, the enzymes used to hydrolyze a starch. So the enzyme that used to hydrolyze a starch is amylase. That is the name of the enzyme that hydrolyzes a starch. Then we have the sugar that makes of RNA is ribose. So ribose sugar make RNA, and the oxyribose sugars make DNA. So the answer is B. The answer is B. So then for the number 39, maltose exists in alpha configuration, beta configuration, then gamma configuration, then D, all of the above. So maltose have alpha configuration. Maltose have alpha configuration. So the answer is A. So let's look at another question. Number 40. Unheating starches. Unheating starches are A, insoluble in water. Soluble in water becomes a regular geometrical shape, no effect of heat. So generally starch is not usually soluble in water, but when you heat it on heating, you make it soluble. So it is soluble in water on heating starch. So the answer to this is, of course, option B. Then so let's look at another question here. The question here says a unit of carbohydrate which cannot be further hydrolyzed to simple compounds are monosaccharides. So monosaccharide is a simplest sugar and it cannot further be degraded. It cannot be further hydrolyzed. Like for example, disaccharide can be broken down into monomers, polysaccharide can be broken down also into monomers, and then oligosaccharide also can be broken down into monomers. But monomers cannot further be degraded, cannot further be hydrolyzed. It is the simplest sugar. A monosaccharide switches from an often change to a cyclic form through a hydroxylation, hydration, nucleophilic addition, and then hydrogenation. So generally, a monosaccharide usually switches to form a cyclic form, and this is done through a reaction. And the reaction that does that is, so the types of reaction that actually leads to the cyclization of monosaccharides is through a nucleophilic addition reaction. It's through nucleophilic addition reaction. So therefore, the answer to this question is option C. So then, the formula for monosaccharides is, of course, this is the formula for monosaccharide. CH2O, open bracket, close bracket, N. So this is the formula for monosaccharide. And then the hydrolysis of glycoside bond involves A, the breakdown of glycosidic bond, B, formation of glycosidic bond, formation of hydrogen bond, D, formation of ionic bond. So hydrolysis means breaking down. So therefore, formation will not even part of what you will think as an answer. So therefore, it's actually the breaking down of glycosidic bonds. So to hydrolyze or to break down glycoside bond, then of course, you need to break down the glycosidic bond because this is the bond that formed them. So to hydrolyze them into individual monosaccharides, then you need to break down the glycosidic bonds. And then the 6 carbon rings have suffix called glucose, fructose, furanose, pentose. The answer is furanose. It has a furanose as a suffix. And then if OH group is to the left of the last stereo center, then carbon, so of the last stereogenic carbon, then configuration is, so if OH group is left of the last stereo center carbon, so that configuration is called L configuration, and that is, and for the one that is at the right is called D configuration. So for the left, when the OH group is at the left, it is called L configuration, and when it is at the right, it is called D type configuration. So then the next question is, which is 7. The simplest form of sugars are usually colorless, water soluble, crystalline, and the all of the above. So the answer is all of the above. So generally, simplest sugar, they are colorless like glucose, and it is water soluble, and of course it is crystalline in nature. So all simplest sugars have this property. So the answer is the all of the above. And then lactose is an example of polysaccharides, monosaccharides, disaccharide, and oligosaccharides. So lactose is an example of disaccharides that made up of glucose and galactose. It's an example of disaccharides. So a method of writing structural formula of carbohydrate represent monosaccharide cyclic structure with a simple 3D perspective is known as, this is what you call Howard's projection. So the answer is Howard's projection. So now we are moving to the last question. So when mixed with iodine, so when you have iodine and you mix it with glycogen, then it now turns to red. So this is actually one of the tests of glycogen. If you want to test for the glycogen using iodine, so you can have a solution, add iodine, and if it change from if it turns to red, then it means that it is glycogen, and if it turns to blue, it means that it is a starch. So the answer is this. So ladies and gentlemen, I hope this video will be of help, and if this is the first time you are coming to my YouTube channel, please subscribe and join as a member. Thank you.